Hello. Today we're going to look at the dot product. All right. So what is the dot product? Let's see what they're asking us to do here. So we're given vectors A, B, and C, and D, where magnitude of A is 4, magnitude of B is 5, magnitude of C is 2, and magnitude of D is 6. And the angles between A, B, C, and D are given. So we forgot about D. C and D are given. Okay, let's clean this up a little bit. I think we're asked to find various things. Let me just fix that. C and D are given below. Are given below. Okay, so we have this nice little diagram, and then we're asked to find the following values. Okay, all right. So first things first is, what is the dot product, or how is it defined? So for two vectors v and w, the dot product is defined. There's a couple of ways to define it, but for these particular exercises, we're going to use the magnitude of v times the magnitude of w times cosine of the angle between v and w. So this is the definition that we're going to use for these particular exercises. So why don't we label the lengths or magnitudes of each of these vectors? So magnitude of A is 4, B is 5, C is 2, and D is 6. All right, so now let's scroll down. Let's do some work. All right, so find the following values. Make this a little smaller so we can get the definition of the dot product up there as well. Okay, so we want the so we want A dot B, so dot product of A and B. Let's start with that one. A dot B, that equals magnitude of A times magnitude of B times cosine of the angle between A and B. All right, magnitude of A is 4. Magnitude of B is 5. Cosine angle between A and B is, interesting, 90 degrees. Okay, so 4 times 5 is 20. Cosine of 90 degrees is what? It's 0. So that's just 0. That was easy. Okay, B, dot product of C and D. All right, so magnitude of C, scroll down a little bit. Magnitude of C times magnitude of D times the cosine of the angle between C and D. What's the angle between C and D? It looks like it's 60 degrees. Magnitude of C is 2. Magnitude of D is 6. Angle between the two is 60 degrees. Okay. 2 times 6 is 12. Cosine of 60 is a half. That's from our special triangles. 12 times a half, 6. Good. Okay. Okay, we've got quite a few left. So why don't we, whoops. Why don't we scroll to the right a little bit to do C? I think we can see everything. Let's try a different color. C. For part C, we want the dot product of A with C plus B. All right, so we don't have the coordinates of C or B. So, what are we going to do? So we're going to use properties of dot product. So A, the dot product of A with C plus B is the same as the dot product of A and C plus the dot product of A and B. Now, we found the dot product of A and B. That was 0. So now we just need the dot product of A and C. Do we have that? No. Let's find that. So that's equal to the magnitude of A times the magnitude of C times the cosine of the angle between A and C. So let's look at our diagram. Okay, so magnitude of A is 4. Magnitude of C is 2. Cosine, that now the angle between A and C is 90 plus 45. That equals 135 degrees. Good. So 4 times 2 is 8. Now the cosine of 135 is negative cosine of 45, or it's related to acute angle, and that's 1 over root 2. So this means our dot product of A with C plus B is negative 8 over root 2. Good. All right, so now we have D. Where should we do D? Let's scroll over to the left-hand side so we can see our diagram and our question. So D, let's put it up here. D, we're looking at the dot product of 2A, dot negative B. Interesting. Okay. So we're using properties of dot product now. So we can take the 2 out and rewrite it like this. You can also take this negative out and rewrite it as negative 2 times A dot B. But we found the dot product of A and B in part A, and we found that that was 0. So it's negative 2 times 0, which is this 0. Easy. Now E. Let's have a look at E. Let's try a different color. Keep them all separate. Like brown. E. Dot product of D with itself. So let's have a look at this. So magnitude of D times magnitude of D times the cosine of the angle between D and itself. What's the angle between an angle of a vector, and itself? It's just 0. So cosine of 0 degrees. Cosine of 0 degrees is just 1. Magnitude of D squared, 6 squared. So the dot product of D with itself is just 36. Or the magnitude of any vector with itself is just the square of its magnitude. All right, and we have one left, F. Let's scroll back over here. Okay, let's pick another color. Let's do yellow. So F, we want the dot product of A with the 0 vector. Okay, so let's write this out. Magnitude of A times magnitude of 0 vector times a cosine of the angle between A and the 0 vector. Well, magnitude of A we know is 4. Magnitude of the 0 vector is just 0. There's no real angle between the 0 vector and any other vector, but anything times 0 is just 0. So the dot product of A with the 0 vector is just 0. Good, and that brings us to the end of our session today. If you have any questions, send us an email at info@raisemymarks.com or give us a call, day or evening. We'll be happy to answer your questions. Thank you for watching.